Welcome to Qt Widgets and More. In today's episode, as you might be able to tell from the headset wire coming down here, I'm going to talk with Pepe, also known as Giuseppe D'Angelo. We're going to talk about the Qt source code, more specifically, how do you read it? Okay, so I asked Pepe in because in multiple episodes already, I've been showing you source code from Qt, and while I might understand most of what's going on in there, there's still a bunch of macros that I'm not 100% sure of, and I was wondering if you were, because reading the source code of Qt or having the source code available for Qt is likely one of the most compelling reasons for using Qt in the first place. You can actually debug your way into the source code rather than if it was just a binary blob. So, Pepe, I asked you to get ready with your Qt Creator, because what I'd like you to do is just walk me through some source code. So, can you like get me over? And by the way, welcome, Pepe.
Hello, Jesper. Glad to be here again.
I'm so impolite. So, could you please navigate over to Q item delegate?
Open up the header for this. Okay, apologies if you see a few red arrows and whatnot. That's because I'm actually hacking on Qt, but I hope that is not going to affect this episode. You can still read that.
We can definitely see through that. But what I'd like you to do is just walk me through, and I don't need to understand what Q_object is or Q property. I understand that. Thank you very much. But stuff like Q require config, Q begin namespace, just two of those that are in my face right now. What do they do? And I don't need to know. Let me just put that in before I let you loose on that code. I don't need to know how to actually develop Qt, because I'm not going to be doing that. But I would like to still know enough so when I get in there in a debugging session that I'm not going to be, ooh, what is that Qt begin namespace? Is that going to change the whole world for me? So why don't we start with Qt required config item views?
Sure thing. First and foremost, let me actually give you a positive piece of information. That is, every time your debugging session brings you into Qt internals, don't be scared by the fact that Qt uses a lot of keywords, magic, macros all over the place. All right. If your mental model is you can ignore most of these, you are actually pretty much on the right track. Okay. But clearly, sometimes these are just in your way, and so you're wondering, okay, why is this there, and what does it do? So yeah, just the first one on this file, this Q require config item views. So that's a macro. It belongs to a set of related macros that we have in Qt, which is used for the so-called feature system of Qt. What in the world is the feature system of Qt? It's a way to build the Qt source code in a way that allows you to select which parts of Qt you want to build and which parts you don't want to build. And to be more precise about this, this is a kind of selection that happens on a very or somehow very little scale, very little grain. That is, you can always say when you build Qt, okay, I don't want to build Qt multimedia because I'm not doing multimedia. So you can always exclude like an entire module of Qt. However, maybe you want to build widgets, so you want them, but for whatever reason, in your application, you're not using item views whatsoever. So you don't want to build a subset of the widget classes. Like, of course, the list view, the table view, the delegates, all of those. So Qt has internally a config system, a feature system, to be more precise, that allows you to fine-tune all these various things. What that macro over there does is actually requiring that if you're building this file, or if you're including this file inside your source code, that Qt has been configured with the item views enabled, right? Because if you build Qt without item views, and you somehow end up including this file, there is a mistake somewhere. You're not supposed to include this file at all because you don't have this particular feature. And as I said, there is a family of similar macros. So this one is the one that you find, say, in a header when you're looking for, and this header requires that particular feature to be enabled. You can also find similar ones inside your source code. So Let me see if I can find some in here. I'm just navigating it through because I know what to look for. I like kind of got a trained eye for these sort of things. Yep. So okay, there's a few around here. Like you can see these other macros that enable or disable code paths. If def Qt not that, if def Qt not that. It's really a kind of a complicated system in which various parts of Qt get enabled and disabled based on a bunch of settings that that you can have. And indeed, inside the source code, sometimes you may find these if-defs that conditionally exclude a part of code, saying, okay, you decided to compile Qt, say, without the Q line edit widget for whatever reason. Okay, so if I have a piece of Qt that is using that, it is to be protected. And that's where inside the source code, you may find this sort of if-def not that, if-def not that. Okay, I'm not sure if there is...
I like how your trained eyes is able to see code that is grayed out.
Oh yeah, it's a feature, it's not a bug. Let me see. Yeah, okay. The one I was just talking about, okay, config qline-edit. Here there is this function somewhere else, q abstract delegate try fixup, and you can see this if qt config line edit. So if you do have it, then this code gets compiled. If you don't have it, this code gets compiled out. And even if you do have it, you may have chosen to not compile out, to compile in or out the validators of line edits. So this even goes one step further.
I love how just the whole thought of you have gone through all the trouble of getting the whole model view framework, table view, tree view, whatnot, but you don't want a line edit in there.
Yeah, I hate line edits.
But seriously, this cannot possibly be tested on CI with the 800 different combinations. So
yeah, that's kind of a bad news in the sense that, as you could say, there is clearly just too many possible combinations of, okay, I want that one in, that one out, that one in, that one out. It's not actually actively tested, but surely any bug report gets fixed quite right away. And if you end up in some particular combination that doesn't work, fixing the build is super easy. It's just a matter of adjusting some of these if defined, if Qt config, and so on and so forth. And I can add also another little thing, that is, I'm going to leave a little link in the video description about how do you know which ones are there? How do you know which ones are the switches that you do have in case you decide to build a stripped down version of Qt? And there's a little web page that you can use to, well, just know about them. And if you want to actually select a subset, and that web page will produce you a config with command line with all the right switches to enable and disable the various things that you may not need. Now,
okay.
Yeah,
we are getting a bit behind ourselves. We're not going to develop Qt here, and we might be recompiling Qt, but we're just trying to understand. So Qt begin namespace kind of indicate that has something to do with a namespace that is beginning there. Yes,
that's also something that is not very widely used, but there is the possibility of building Qt within a namespace. By default, Qt isn't built in any namespace, so you just write Q whatever, Q object, Q widget, Q item delegate in the global namespace. But you can build Qt confined within a namespace. Again, it could be convenient. So Qt needs a way to add the namespace, whatever name you chose, and of course to close the namespace after it's done. And this is what these macros expand to. So this by default expands to nothing. But if you then told Qt, please sit inside the namespace Qt6, Qt5, or whatever you want, this expands to namespace Qt6 curly brace. And clearly there is a matching one down here, Qt and namespace, which is the closing curly brace.
Fair enough. And if you scroll back up again, I see a class Q widgets export. That's just the whole idea about compiling libraries with export or import of symbols, right?
That's right. This right. Is also another macro that expands to the right thing when you compile the class.
That we have covered in one of the episodes in Qt Widgets and More, where we talked about plugins for designers. So if you're interested in that, just go and look at that URL right over here. Okay, let's have a look at the C++ code. There wasn't all that much here in the in the headers file,
Yeah,
but
sure.
in the C++ code, I'm sure we can find more interesting.
Let's jump into, I don't know, set clipping, because for whatever reason, my eye fell on that one. So say that you are calling this function from your C++, from your application code, and then you step through the bagger, you end up in here, and you can find more macros, QD, and you can find more mysteries. So you may be wondering what...
Yeah, indeed. I mean, on line 363, there is a D pointer. I mean, where did that come from?
Yeah, if you go look into QItemDelegate, you will not find anything called D, and there isn't a parameter called D, but there is a macro in here called QD, and that is the mystery, that solves the mystery. What is that macro? What is that D pointer? In general, Qt classes employ the so-called pimple pattern, or private implementation pattern, also known in Qt as the D pointer pattern. In a nutshell, each and every class in Qt, like QItemDelegate, has got a counterpart private class that works behind the scenes. That private class is linked to the public one, and the public one is linked to the private one. There are pointers in both directions. And this D pointer is actually a pointer to my private class. So here I'm inside QItemDelegate, I'm inside the public, and let's suppose I want to reach for my private class. How do I go there? Well, I need this little pointer to point to my private class, and then I can access, whatever thing is this, whatever property this is accessing. And in order to get this pointer to my own private class, I'm going to use this little macro coming from Qt, which is called Q_D. The point of that macro is to simply introduce the D pointer inside the scope of this function. So now I do have a D pointer and I can follow it, and this will land into my QItemDelegate private class, which is what I want to modify here.
There's some magic going on behind the scenes here. I don't understand entirely. How can you possibly have a function that just creates that D point? I understand you must have something more than just that Q_D somewhere else.
Yes, that's right. So Q_D simply introduces the D pointer here, but where does it get it from? Like, okay, how does this class, how does this object know that there is a counterpart called QItemDelegate private? That is done inside the QItemDelegate class itself. So if I go look inside this class somewhere, likely down here in the bottom, you can find it. You can find that a little macro called QDeclarePrivate QItemDelegate. And the point of that macro is to declare all the helper functions, all the helper functionality to enable the use of QD inside my source code. And yes, if you're wondering, wait a minute, where is that ItemDelegate class? Okay, and how is
why do I even need to be on that show? That was my line.
Oh, right. So if you're wondering, wait, why does Qt go through all this trouble? Why? Oh, maybe it's a more broad question, like what is the pimple pattern for in the first place? It is for two important things. I'm going to tell you both, and I'm going to tell you why it matters for Qt and why it also may matter for your own source code. The pimple pattern allows Qt to catch, say, 3 birds with one stone, or 2 or 3 birds with one stone. The first one is not that interesting for you as an application developer. That is, the pimple pattern is generally speaking used to isolate the implementation details of a class from its public interface. This means that every time I need to, I don't know, modify my QItemDelegate in any way, let's say I want to add a new data member, a new field, okay, I'm not going to touch this header file right here in any way. I'm going to open the private class, I'm going to add the functionality in there, and I'm going to modify the C++ file for the QItemDelegate. This means that classes or any code which is using this header, which is including this header, does not need to be recompiled when I modify this class. And that's great. Okay, this reduces compilation times. Now, clearly, this is not a concern for you because you're not building Qt. Okay, you don't care about building Qt or developing Qt in a faster fashion. But this is actually the reason why you may want to employ the pimple pattern, the D-point pattern for your own application code, because it's a
you're basically taking the private part out of the class.
Yeah, Precisely. You're isolating all the private bits into another class. You're linking the two classes together throughout these markers or throughout any mechanism you want. And then every time you need to evolve with this class, you act on the private part, not on the public part. And especially if your class is something central, something that is included by 1,000 other places or 10,000 other places, you really don't want to touch that header ever, because you know that as soon as you do that, this means recompiling the half of your application. And we don't like that. So that's one way of seeing this. Okay, this is a good way for Qt to reduce its own compilation times, and that's why you want this pattern also inside your own application. Then let me tell you about the second important thing, which is actually important for Qt and your application, which is this is also a mechanism through which Qt can preserve binary compatibility. Now, what I'm talking about here is the fact that Qt comes with a promise. That is, you can build your application against Qt 5.12, okay? And then you can upgrade the version of Qt to Qt 5.15 without the need of recompiling your application. So Qt has this so-called binary compatibility promise. You can upgrade Qt to a later version without the need of recompiling your application. This works, let's say, only if the memory layout of anything which is Qt related does not change between the two Qt versions. Because if it does, then the compiled code of your application is going to do the wrong thing, is going to access the wrong memory layout for the Qt objects and whatnot. So a neat way to guarantee that is to make each class that your application uses kind of simple, kind of dumb. In reality, what your application uses, this Q item delegate class, is nothing but a pointer. To what? Well, to a private class which is managed by Qt entirely. So what you do with your Q item delegate class does not change across Qt versions, and this way Qt preserves binary compatibility.
And I'm glad that you did not answer the question that you set out yourself to ask before. Namely, where is that private class? Where do I find that in the source code?
Oh, that's right. Let me show you. So suppose that you want to dig into that. So you found the Q item delegate and you want to find the counterpart. By convention, this counterpart can, let's say, only be in maximum 2 places inside Qt. One easy way that we're going to see right here for Q item delegate is that the private class is actually just defined inside the C++ file. So if I open QItemDelegate.cpp and I scroll all the way up to the top, here it is. You can find right here the class QItemDelegatePrivate. So again, that's a private class. No one is meant to use it except QItemDelegate itself for its own implementation purposes. So I'm just going to define it entirely inside my CPP file, okay? And I'm going to use it entirely from within this CPP file. So that's one way to find it. There is a second possibility, which is sometimes Qt may want to share these private implementations across multiple places. So it needs to isolate the private implementation classes inside a header file. Now, you as a user are not meant to use that header file ever, right? Because it's a private header file, something that Qt uses internally. But nonetheless, it's there, it's on disk. You may be tempted to reach for it and grab it. And so for that reason, that file follows a specific naming convention that should make people realize what I'm really doing here. Am I really supposed to include that file? And the naming convention is simply the name of the class. So in this case, QItemDelegate _p for private.h. Okay.
Ah, that's what the _p files
right.
are.
So let me open, for instance, this one here, right? You can see that QItemDelegatePrivate needs this either private class because it wants to inherit from it. This means that this class has been isolated in a header. So what's the name of the header, Jesper?
Well, it's called QAbstractItemDelegate
Yep.
_p.h.
Yep, precisely. QAbstractItemDelegate.p_p.h. It's this file right
Warning.
here. Okay, so here you can see an example of these.
And may I just interrupt you here? Just
yes.
as a feature request for Qt Creator, if anybody from the Qt company is watching this, if you could just scroll up there.
Yes.
Why is the text warning not blinking? Sure, we could add that to Qt Creator.
Oh yeah, yes, big red and blinking. Yes. So that warning is there to complement what I just said. Like in case you end up including this file inside your application, Qt is telling you, watch out, you're doing something that it's not part of the promise of the Qt compatibility. Okay, we can do whatever we want to this header. It's private stuff, so don't rely on it.
And in honesty, it is only very few people that ever needs to get down. And I mean, we have been talking in many times in this show here about Gamma Ray, which obviously need to know everything there is to know about your application, and it is using private headers here and there. But in a regular application, at least personally, I have never been in the need to go down there.
Yep, that's pretty much it. Either you're building something very sophisticated, or perhaps you're working around some bug and you need to fiddle with Qt internals for one specific Qt version. But generally speaking, there should never be the need for you to access private stuff to do things. If you're missing something from Qt... Sorry.
I love how after I said I never used it, that your next sentence was, yeah, either you build something sophisticated. Thank you, Pepe.
Oh, yeah, well, you do build things sophisticated, but you may want to access this stuff from time to time. So they're still there, they're still available. Just watch out what you do.
Certainly you occasionally end up debugging your way into this private header and learn something from it. That's for sure. Okay, so private headers. I also found directories that were called private. Can you say anything about those? Or
so the directories that are called private are where these private headers are installed in a installed Qt build. So if you're so if you have an installation of Qt, which means you don't actually have the Qt source code, or maybe you have the source code on elsewhere on your disk, and you have just an installed build of Qt, like the one that comes from the installers, then actually there is a split between the directories. The public headers are put in some directories. The private headers are further down, isolated into a private directory. Yeah, we're really trying to make it hard for people to accidentally include something like this. So you need to do some work to end up including this. It's not rocket science, but that's where those private directories are for. You can see it one, for instance, over here, line 56.
Right. Okay. So in this file here, I actually also found something called QPrivateSlot, if I remember correct.
Okay. Well, it's not in this file, but perhaps in its public.
Anyway, there's right. What I got was this _Q_. Well, yeah, there we are.
Right.
Q_Q_ commit data and close editor. You couldn't be more verbose with that name, could you?
Yes and no. It is another name which is deliberately evil to make people realize you're not supposed to use this function. So let me discuss what that even is. So, well, you can guess pretty much what it is because the macro says it all, right? This is a slot, so something that you can connect to. There is the target of some connect done somewhere. But it's private. That is, it's not meant for you, end user, to connect a signal to. This is just meant for Qt internal purposes, that it needs to hook up this function as a slot to something. All right. Now, if I did call this one simply commit data and close editor, suppose that I did something like that. All right. And now suppose that you're developing your application, you start typing connect something to this object, and now Qt Creator is, very kind and offers you, okay, what do you want to connect to? And here's all the slots that this object has. Now, if it offered you this possibility of something called commit data and close editor, you may think, yeah, okay, I know that's what I want to do. I want to commit data close editor, and so you could be tempted to connect to it, even though this is not a slot you're not meant to connect to. Okay, and that.
But where is this slot? I mean, if I look at the first part of this this Q private slot, it says d_funct, which kind of gives me a feeling that we're talking about the D pointer here. So is this slot on the public or the private class?
So, so how do we isolate this slot into Qt? We do two things, well, three things. We name it in an evil way, so you're not supposed to connect accidentally to it. We mark it private. And also, we don't actually implement it in the public class. Okay, if you look at this class, the QObjectItemDelegate, from a C++ point of view, this function does not actually exist in here. So this function is defined on its D pointer, so on its private counterpart. If I open up the private counterpart, now you do see that function properly declared, and clearly this is also going to be implemented somewhere. I hope that makes sense.
So you lost me here, Pepe. Why not just have that as a slot in here?
Okay, so you say that sounds like a layer of indirection that I may not need. Why is this not just a regular slot, but in the private class? And the reason for that is that if you take a look, the private class is not actually a QObject. It does not inherit from QObject, it inherits from QObject private, the counterpart, the private counterpart of QObject, but this isn't a QObject. So you cannot have ordinary slots inside this class. So you have two possibilities pretty much. Either you declare a custom utility QObject subclass with this one slot, and then you connect to that. So you create an object of this utility subclass, and then you connect to that. Sure, that works, but it has a limitation, which is a QObject is kind of a heavy class. All right, it's not for free. Now, I'm not saying that it's the end of the world. It's probably, you know, a couple of hundred bytes of memory. But surely it sounds kind of an overkill for something that you can obtain in a slightly different way. And so that's why this code did not go for that specific solution. Instead, what Qt chose to do is to say something relatively simple, which is this. Say, wait a minute, I do have a QObject subclass. It's my public counterpart. Okay, so is there a way to just add a slot to that class and not to my private one, but in a way that doesn't make that slot usable to the to the bigger audience? And so this is the solution that Qt came up with. That is a way to say, I do need a slot. Okay, this slot is not implemented inside this class. It's implemented in the private class, and this slot is not meant to be used by, again, the general public. Now, if you do open up something like Gamma Ray, and you pick up a delegate and you see what are its slots, you may find that this thing is actually there. Okay, because this is, for all practical purpose, a slot. Okay, this is something that the mock is going to record and register into the meta object. So you can introspect this slot. You can invoke it through QMeta object invoke and similar facilities. It is, for all practical purposes, a slot, except that it's not a slot that you want to invoke yourself.
So with the risk of giving away all I know about Qt here, one of my audience, not that I did ask that myself in the rehearsal here, absolutely not, but one of my audience might ask why the _Q_, after all, it's a private slot, so you cannot connect to it anywhere but inside of the class, right?
Yeah, so let's open that specific chapter. That is, what is truly a private slot? I mean, why is it spelled like that? And we ask, why is it not just spelled like private slots or something like that? Avoid commit data close editor. Okay, I'm just doing some live coding because why the hell not? I like it. Well, that's what I do the entire day, so I keep doing it. So why not spelling it like this? Okay, would this also impede connecting to this slot? The answer is unfortunately no. You can still connect to this slot, or you can still trigger this slot in at least a couple different ways. Sure, if you try the new syntax, the pointer to member function syntax for connecting, you can't do that because you're not allowed to take the address of a function which is private. So the compiler is going to block you right away and will tell you, you can't do that. You can't take the address of a private member of a class. However, if you use the old syntax, the macro one with the SLOT, slot all uppercase, that one will actually let you connect to the slot. Okay, the slot is still there and you can still connect. And that connect disregards the private keyword. Okay, because it has actually, since it's an entirely runtime operation, it has no mean to check where am I connecting from? Am I connecting from the same class, so that's good? Am I connecting from the outside? That information is not available, so the connection will succeed. And also some other QMeta object related facility, like QMeta method, QMeta object invoke. There is all these very nice introspection / reflection tooling inside Qt, all these classes. They will all let you invoke this slot from the outside. So this solution won't stop those use cases. As I said, if in Creator you have this and you try to connect to this, Creator will still offer you the auto completion, and people may be tempted to connect to this no matter what. So how do we disable it? Well, we discourage it at least by naming it in a very evil way. So you see that, you think about, hopefully you think twice before connecting to it. Okay. And then the second thing is that this is really meant to be something which is implemented entirely on the private class. And that's why this is actually defined in the private class itself.
Mm.
Okay.
Okay. Fair enough. Moving on here. I'm just looking around your screen and I see this Q_signals. Oh, you want to delete that?
No, sorry. Let me go back to that.
I would imagine that would this afternoon sitting there compiling it like, what? Wait. Oh, yes, but right. Now, moving up to Q_signals. What is that about? Why not just signals? And I also seen public slots or Q_slots or whatever it's called.
Right. Yes, I should have actually mentioned that this should have been Q slots and not just slots. But so both signals, lowercase, as well as Q signals are macros, and they both do exactly the same thing. They're both markers for mock to extract this information from the class, to implement these three functions here as signals. The difference is just how do you spell this as far as the compiler is concerned. When the compiler sees this, of course, it knows, okay, you cannot have this inside a class. You cannot have this particular identifier here that defines a section called signals. So this macro has to expand to something. And indeed, in case of signals, it expands to public. In case of slots, it expands to nothing at all. So the compiler does not even see this, just is public or private, and the compiler is happy. So what is the deal? Why there are two possibilities? Why can I spell it signals, or why can I spell the Q signals? The second spelling, this one with uppercase Q, is there to prevent possible clashes. That is, if you use this header inside a bigger project, something that, for instance, is mixing Qt and other libraries that may also define signals as a macro, then you may get a clash there. Okay, so there is a way to disable all the lowercase magic keywords from Qt. There is a little macro that you can enable, and this will disable them all. And yes, that macro is enabled for Qt itself. So this being an header that Qt does not know where it's going to be used, Qt tries to be a little bit conservative, and so it uses this spelling for all of its macros, Q slots, Q signals, and other Q uppercase things, in an attempt to avoid all these clashes. So even then, if you end up mixing this particular header with, say, boost signals, the two won't clash on the signals keyword, because it's not going to be defined by both of them, only by boost.
Or even worse, you include a Qt class, and then afterwards you include your signal processing library that has a variable called signals in it.
Of course, right. Of course.
Yeah.
The danger of defining macros which are simple, like signals, is that somebody somewhere could have just defined int signals, and now you have a problem. All right. But you can disable it even for your own source code. I would claim that maybe it's not necessary in application code, but it's a good practice to actually disable the lowercase macros, because you never know how big your application will become. And the day you start pulling in third parties, you may get clashes. Okay. And Qt, of course, doesn't know this.
If you ever get in that situation, I'm sure that Perl or Python or Shell script or Seed or Awk or whatever will help you change your signals lowercase to Q_signals. That should be relatively easy.
It is.
Anyway, talking about private here, we saw Q private slots, but somewhere I actually saw something called Q private signal that made me, what's going on there? Can you enlighten me about that?
So let me see if I can find a good example. Actually, I probably have a couple of good examples. We're talking about model view. Let's keep talking about model view, which I'm told it's a very favorite subject of yours, given the number of videos on YouTube about the topic of creating models, testing models, making them more robust and whatnot. So let's go to the to the root of them all, the QAbstractItem_Model class. Yeah, you know that class. I know you do. And let's have a look at some of its signals, which are declared, somewhere down here. And you may spot that in several of these signals, not all of them, but several of them, these signals carry a last argument, or in this case, just the one, called QPrivate signal. You see that? It's a little bit all over the place. Here, okay, these two signals have only that argument. So you may be wondering, what is this all about? And why does Qt bother, and should I ever bother myself about that particular thing? So this particular argument is a form of safety, or safety net that Qt wants to employ to prevent two possible mistakes regarding emitting this signal. Okay, what are these two possible mistakes? The first possible mistake, and this is just in general, is the fact that a signal is just an ordinary function of any given QObject subclass. Okay, this is a function. It's not a function you implement, it's a function with special semantics, but it is a function. And the way to emit a signal is as simple as calling that function. All right. Now, there could be the case that somebody accidentally ends up emitting a signal of a given class from outside the class itself. So say that I have a QAbstractItem model, because I have one, I have a model, and I want to reset the model. How do I reset the model? Well, maybe I just call model reset. Okay, so I just type model.model reset. Should that compile? No, it shouldn't, right? It should not compile at all, because that's not the right function to call, by the way. But, you know, it's called model reset. I may think, right, that's the function to reset some model. So,
been there, tried that.
Sorry?
Been there, tried that.
Okay, right, yeah.
Got the t-shirt.
Yep, it may happen, right? So how do we avoid that? Thing number one. Now, you may be thinking, wait a second, doesn't the signals section prevent people from the outside to, call a function? The answer is unfortunately no, because what does the signals macro expand to is merely...
You mean before or after the bug was introduced?
Yeah, the bug, yes. What does that signal, what does the macro expand to? In Qt 5 and 6, which are the only Qt versions I'm going to talk about today, that macro actually expands to public. Okay, yes, in the past it used to expand to protected, but these days it does expand to public. So these are actually public functions. This means that from the outside of this class, you can accidentally trigger a signal. We don't like that. We'd like to prevent as much as possible this from happening while knowing that these are actually public functions. So that's problem number one, okay? Somebody from the outside triggering a signal accidentally. There is also problem number two, and I like that I chose this class to represent that particular problem, which is this. Sometimes a class like QAbstractItem_Model is a class which is meant to be subclassed. It's an abstract class indeed. And sometimes from within your subclass, you must emit certain signals at certain points in time. So you have done countless videos discussing the QAbstractItem_Model API, which is fairly complicated. There is a lot of things going on. and we have discussed, for instance, okay, whenever the data inside your model has to change, remember, you have to emit data change. Otherwise, the views will never know that some data has changed. So remember to emit the signal. Okay, that's fine. So this means that the subclass, a subclass of QAbstract item model, is required to emit certain signals, like data change. It's one of them. But there is also a bunch of signals inside QAbstract item model that a subclass is not supposed to emit ever. For instance, if a subclass inserts a row inside of it, inside its data structure, it's not supposed to manually emit the rows inserted signal. What it's supposed to do, it's supposed to comply with the API, which is complicated. Please look at the Jesper's playlist about all of this. But in a nutshell,
right up here,
yeah, right somewhere in some corner. But in a nutshell, what it is supposed to do is to call begin rows inserted and rows inserted. It's supposed to call other parts of the QAbstract item model API. And those parts will take care of emitting the right signals at the right time after doing some internal bookkeeping and whatnot. So you now have signals that you don't want anyone to emit except the class itself, right? This is what this QProvideSignal argument does. This prevents anyone but the class itself to emit the signal, because number one, it could be from the outside, that's clearly a mistake. But number two, in some cases, you don't even want subclasses to emit those, because it's a symptom of some other mistake. It's a symptom that you're not calling the right APIs.
And Qt4's protected queues or signals being protected wouldn't even have helped us there, I guess.
There we go. Yes, this second case, the one from the subclasses, would even make you fall into this trap, even if this macro here still expanded to protected like it did in Qt4.
So who's implementing, or where is that QPrivateSignal class?
So this is actually for free, in the sense that this data type, because it is a data type, right? It appears on signature, is actually provided by you by the expansion of the Q_object macro. Okay, so the Q_object macro, yeah, that one again, it expands to a bunch of different things, including a little private type called QPrivateSignal, which means now that you have a type which is inside your QAbstract item model class. It's a private type, so no one can build that type from the outside. Not even a subclass can build it. And so this, long story short, ensures that only this class is the one that can emit these signals. Okay, somewhere in the C++ file, for instance, let's check where this signal here is emitted. I can just jump into the implementation and check, well, I guess I can check emit. Yeah, here we go. You can check the emission. In order to emit this signal, I must build an argument of type QPrivateSignal. And since this is a private type, only me and no one else, not even my subclasses, can actually build this argument. Okay, and that's all good and that's all nice, because it effectively prevents a lot of mistakes when using when I would say implementing classes that deal with signals. That's
excellent.
Yeah.
Okay, I think that concludes all the questions I had when looking at the source code. And as I said, you do have the source code. Do compile Qt yourself, so that when you debug into the source code, you're not debugging into a binary that is built with -0.2000 or whatever the maximum optimization level is. And that will actually make it pretty easy to spot what is going on behind the scenes. I can't count the number of times I've debugged my way into the Qt source code, despite that I've never written a single line. Well, wait, I've wrote many lines of Qt source code, but not many lines of the source code of Qt. Anyway, thank you for watching Qt Widgets and more. I hope you enjoyed this episode, and maybe there will be an episode out there one day that will tell you about all the steps required for you to actually commit to the Qt source code itself. Pepe, thank you very much for joining us.
You're very welcome, Jesper. Thank you for having me.
And until next time, have a great time.